This call is now being recorded.
Topic name is multiple access, that is part 2. Here we will cover controlled access, means the stations consult one another to find which station has the right to send. Like in this example, before sending something, each sender has some reservation kind of thing. Like here 5 senders. Sender number 1, 3 and 4 has bit as 1. Ones mean the sender has data to be sent. So that's why here you station 1 and station 3 and station 4 has data to be sent, since their corresponding bits are 1. Similarly, in this fragment, stations 1 has data to send. Okay, so this is known as reservation method. In polling method, if A and primary server, between this primary will poll. Okay, if A has nothing to transmit, then it will send NAK, not acknowledgement. Okay, if B has something to be sent, then after getting poll, it will reply with data and then it will reply with ACK. Okay, that is polling. Okay, poll based data transmission. Okay, in case of channelization, multiple access method in which the available bandwidth of a link is shared in time, frequency or so forth between different stations, it is known as channelization. Okay, here we 3 categories are there: FDMA, TDMA and CDMA. In FDMA, frequency is divided among senders. Like sender 1 uses the 4th layer, sender 2 uses the 3rd layer, sender 3 uses the 2nd layer, sender 4 uses the 1st layer. The whole available frequency is divided among the transmitter, and this frequency will be available for the whole time. Okay, so FDMA means available bandwidth of the common channel is divided into bands that are separated by guard bands. Okay, what is TDMA? TDMA is time division multiple access. In case of TDMA, the total frequency, total band will be shared among the senders based upon time. Like time 1 is available for transmitter 1, time 2 for transmitter 2, time 3 for transmitter 3, time 4 for transmitter 4. Means the whole available bandwidth can be used by 1 for time slot 1. Okay, that is the concept. Okay, you divide the time. Okay, TDMA means bandwidth is just one channel, that is time shared between different stations, is known as TDMA. Then what is CDMA? CDMA means it uses one channel that carries all transmissions simultaneously. In CDMA, for sending data D1, it uses a code. Okay, for sending data 2, it uses a code C2. For transmitting data 4, it uses C4. For transmitting D3, it uses code C3. So what it does, for first sender, data into code plus data into code for 2, data into code for 3 and data into code for 4, and some of them will be transmitted from the sender to the receiver. Okay, so after receiving this, at the receiver side it will decode the data. So for example, as I have shown here, C1, C2, C4, C3. Let's take 4 chip sequences where all are taken as positive. Here, say plus minus for C2, plus minus for C3, plus plus for C4. Consider that C1, C2, C3, C4 are 4 chip sequences taken for taken for 4 chips. Okay, so what it does, like if this is chip sequence, now let's consider data bit. Like for 0, -1 is used, for 1 +1 is used, and for silence 0 is used. Okay, so your options for data are -1, +1 and 0. Okay, -1 for 0 bit, +1 for 1 bit, 0 for silence. So what happens now? Say bit 0 to be transmitted by sender 1. Means bit 0 means it will be converted to -1. Okay. Say transmitted 2 also, it will be -1 since it is bit 0. And for C3 it is silent, so bit will be 0. And for C4 it is +1, so our bit stream are -1, 0 and +1. Now your data D1 is -1. You multiply D1 with C1 to get this value. You multiply D2 with C2 to get this value. Okay. Similar way, you multiply your D3 with C3 to get 0, 0, 0, 0. Multiply D4 with C4 to get plus -1, -1, +1. Now you add all of them to get you get -1, -1, -3, +1. So that will be transmitted from sender to the receiver. Okay. So if your digital signal created by 4 stations in CDMA, so it will look like this: -1, -1, -3, +1. Okay. So this data is represented on the channel. Okay. So what it does, for each station it adds the values. For each stations it adds the values. Okay. For each station it adds the values. Okay. So this will be transmitted from sender to the receiver, and the receiver, it will receive this data and it will multiply this data with the corresponding chip sequences for like for station 2 code, chip sequences is plus, minus, plus, -1. You can revise it again. Chip sequences for your C3, sorry, C2 is plus, minus. Okay. So you now multiply this with this to receive this inner product, where it is -3, -1, +1, -3, and it is -1. Okay. So after adding all of them together, you will receive -4. -4 divided by 4 channel, so you will get -1. -1 means it is bit 0. Okay. If you have not understood this, check this again. If you have received D1 into C1 plus D2 into C2 plus D3 into C3 plus D4 into C4 in the receiver side, okay, and if you multiply with code sequence C1, then you will get D1. Similar way, at the receiver side, if you will multiply the data with C2, you will get D2. Okay, where I am representing R as this circle. Okay. Similar way, if you multiply R with C3, you will get D3. Okay, how to get this? Like if you will solve these multiplications, at the end you will get d1 into n. Okay, so n is here 4, means 4 stations. Divide this with n, okay, to get d1. Okay, so this is the concept. Have you understood?